So this is lesson 4, understanding decay. So we have notice and wonder. We have 2 tables here. So what do you notice or wonder about these 2 tables?
Each is like what they're comparing. If they're trying to compare.
Okay, so what they're comparing. We don't know that, right?
What it is. What do the X and the Y stand for in the graph?
So what do they stand for?
How do you get halves? Like, are you
Okay. So what do you notice about the sequence between the x's? If you just look at the 2 x columns, what do you notice there?
that it's all like
It's all 1, 2, 3, 4. So the x values, or the x values. Oops. Undo. Are the same. Okay. What do you notice about the y values?
those are all different.
Do they all start at the same point?
Yes.
Y values start at 2. Okay. So in both tables they do. If I look from 2 to 3.5, what is the difference there?
Hold on, I gotta get it.
1.5 or 1 1/2, however you want to write that one. I'm going to put 1.5. What about between 3/2 and 5? What's the difference there? 1/2. What is the difference between 5 and 6/2?
2.
Mm-mm.
No, 1/2. Wait.
1 1/2.
Oh.
So 1.5 still.
6. Oh, I was thinking something else.
And then between 6.5 and 8, how many is there?
2.5.
2.5.
No, it's not.
Wait, 6?
It's still 1.5. So what do you notice about our factors there? They're all a difference
1.5.
of 1.5. So we're always adding 1.5 on this side. What about over here? What's the difference between 2 and 3? Okay. What's the difference between 3 and 9/2?
1.
Point
0.89.
5?
Okay, wait, what?
0.5?
It's going to be 1.5.
Again?
1.5. Because 9/2 is 4.5. If we subtract the 3, which I should line that up, you'll get 1.5. What about here?
2.
Hold on.
1.
Let's first put this as a decimal, because I think you guys would prefer to see it as a decimal. So what is 27 divided by 4? What is that close to?
Wait, no, 6.
6. So 6 is 20. 6 times 4 is 20.
26?
Okay, so here, let's do some long division over here. 6 times, sorry.
28. It's 28, right?
Okay, 6 times 4 is 24. So if we subtract 24, what's 7 minus 4? Okay, so we'll add our decimal point in, drop down our 0. What is 4 divided by 30? Or 30 divided by 4, I said that backwards. 30 divided by 4. Does that divide evenly?
No.
No. So what do we need to put here?
Or 0?
How many times does 4 go into 30?
8 times.
8 times. But not even.
7. What's 7 times 4? 28. So we drop down our 2. We add 1 more 0. How many times does 4 go into 20? 5 times. Okay, so we're going to go from this right here is 6.75, and this is 4.5. What's the difference there?
0.5 or 1.5.
Drop down your 5.
2.5?
2.25. Okay. Can you see a pattern for this? Is it easy to see a pattern here? What about 81 divided by 8? How many times does 8 go into 8? 1 time. So we drop down our 1 because that's a 0. Does 8 go into 1? No. Okay. Drop down a 0. How many times does 8 go into 10? 1 time. We subtract our 8. We get 2. We need to add another 0 and drop it down. How many times does 8 go into 20? Twice. What is that? 16. So we subtract that and we have 4. Can 8 go into 4? No. So we need to drop down one more 0. Oops. Undo that. How many times does 4 go into 80? Or sorry, how many times does 8 go into 40? That's what I'm trying to say.
5 times?
5 times. What's 5 times 8? 40. So that becomes 0. So here we have 10.125. The difference here is going to be 3. I have it written down somewhere, but I don't remember it. So let's just do it really quick. 10.125 minus 6.75. Drop down that 5. 12, 10, 9. That's 7. Oops. 3, 3. 3375. Okay. So what can we see here? Our y values, are they the same? The differences there? No. Are they increasing or decreasing?
Well, they will be increasing.
Increasing.
Oh.
Increasing. But not the same. What else do you notice here?
They all start with 1, 2, 3. It goes 1, 2, actually, no, that's wrong.
That's okay. We ready to go to the next part?
Yes.
Okay. What's left? So here is one way to think about how much Diego has left after spending 1/4 of $100. Explain each step. So for step 1, we have 100 minus 1/4 times 100. So step 1 is going to be the difference between 100 and 1/4 of 100. Step 2, we have 100 times the quantity of 1 minus 1/4. So this is either going to be factoring out 100, or applying the distributive property.
Just sit down.
Shut up.
Okay, so here is what you can think of whenever you're doing this. So if we're pulling out a 100 here, that is from this 100 and this 100. Okay?
So there's only one as you go down?
So what we're saying is This is like 100 times 1.
Confusing. This is a lot harder than what we were doing.
So, as I was saying, we have 1 times 100, and then we have 1 minus 1/4 times 100. So what they did here is they pulled this 100 together to be right here. So we are taking what 100 is multiplied by and just subtracting those two numbers. You'll get the same answer.
Oh, so it's the same thing. It's just getting.
It's the same thing. It's just pulling it together. Okay? Okay, so let's do here. So from here, from step 2 to step 3, what did they do?
Wait, I have a question.
What's that?
Is it, if it's 100 minus 1/4, is it minus 1/4 or minus 1/4?
So here you have to make sure that you do your multiplication first.
Okay.
So here it would be 1/4 times 100 before you do 100 minus 1/4. You have to do the multiplication first. Why do you have to do multiplication first? Because of PEMDAS. What is PEMDAS?
Oh wait,
Parentheses, addition,
multiplication.
So order of operations is what it's called, but it's parentheses, exponents, multiplication, division, addition, subtraction. Okay.
Oh, we have no homework.
So what did they do between step 2 and step 3? What's the difference between here and here?
They multiplied the
You took away the 1. Oh, wait.
Did they? They multiplied the parentheses.
They just subtracted in the parentheses. They solved the parentheses. So they reduced, or not reduced, replaced. That's the word that I have over here. Replaced 1 minus 1/4 with 3/4.
That was quick.
Oh, goodness. All right. What happened between step 3 and step 4?
They got shorter. They just switched places.
They switched places. What property is that? Starts with a C.
Configured.
Compensation.
You.
Commutative.
Yeah.
Commutative.
Property of multiplication. All right. So a person makes, let me fix that in, $1,800 per month, but 1/3 of that goes to her rent. What two numbers can you multiply to find out how much she has after paying her rent?
18,000 and
1,800.
Oh, 18.
That's a big old
Whatever.
number.
I just
1,800 and not 1/3, because that's how much she's paying. How much does she have left? So if she pays 1/3 of her money, how many thirds of her money does she have left?
3.
2/3. Is that what you said?
Yeah.
Yeah. So
liar.
No,
You-
I said 2. I was confused because Brady said 3.
okay, so it is 2/3. So if she's paying 1/3, she has 2/3 of her money left. So if you multiply 1,800 by 2/3, you will get how much she has left over. Okay? So write an expression that only uses multiplication, and that is equivalent to x reduced by 1/8 of x. So what am I going to multiply here?
X and 1/8.
Not 1/8. So we're reducing x by 1/8. So it's like the last situation where we had 1/3 going to rent. Now I have 1/7 going to rent. How much do I have left over? Or sorry, 1/8.
I don't know.
So if you have 8/8. No, here we go. You have a whole pizza. It's put in 8 slices. I take a slice out. How many 8s do you have left?
7.
7 8s. So that's what you're doing here. 7/8. And then you're going to multiply by X.
10, 11, 12.
Let's go to the next page.
This is like confusing.
Okay, so the way I explained this earlier, I'm going to go back to this page. You can,
That's
no.
easy.
Okay, you can stay on the page that you're on. I'm going to flip back to this problem because this is where I did this earlier. This is an easy way for you to be able to tell how much things cost. I use this kind of method whenever I worked in retail. So let's say I walk into a store. They're having 30% off of everything in the store.
So 3 pieces of the 8. Right? Or no?
No, different.
Pizza.
Different thing. So if I want to find out how much let's say I'm looking at a cardigan and it's $36.94. I want to know how much that's going to cost with the 30% off.
Divide.
I don't want to divide. I want to multiply by one number. What am I going to multiply by?
3.
No.
What? 0.
So 100 minus 30 is
20.
7.
70.
70. So I want to multiply by 70%. Because that's how much I will pay of the ticket price. So if you walk into a store and they have 25% off, what do you multiply by the cost to find the price?
85?
What, 25% off? What's 25 plus 85?
I don't know.
Is it more? It's more than 100%. So 75%. That's what you're paying as the total cost. So you just multiply by 0.7 and then you move your decimal point over once you have multiplied it out. This is useful. It is a little difficult to wrap your brain around. It's the same process as you did up here. You could do your total amount minus the amount times the fraction. This just takes out the subtraction part. Okay, so let's do this part over here. Now we have the value of a vehicle. Every year after a new car is purchased, it loses 1/3 of its value. Let's say that a new car costs $18,000. A buyer worries that the car will be worth nothing in 3 years. Do you agree? Explain your reasoning. Do you agree that the car will be worth nothing
In 3 years?
in 3 years?
No.
Why not?
Because it's a car.
Elaborate on that.
Cars usually last longer than 3 years.
Well, it depends.
Why would the value not go to zero if it loses 1/3 of its value every year?
Because
Well, why would it lose its Is it getting older? In 3 years?
But then why wouldn't it be zero?
because I don't know, it
So let's
loses
just scraps.
one. I don't know.
Okay, it loses 1/3 of its value. If I multiply 1/3 by 3, that should be a whole, right? Why is the cost of the car not going to be $0 from 18,000?
It's unrealistic.
It's unrealistic. Why is it unrealistic?
Who's gonna buy a car for free?
Well, that's not how that works.
You're not gonna buy it all.
So it's because each year the car's value will be multiplied by 2/3. The value each year changes, but the 2/3 goes to the new value. So it is because each year the car's value will be multiplied by 2/3. So write an expression to show how to find the value of the car each year listed in the table. So if the car is $18,000 at the purchase time, what am I going to multiply to get the cost or the price, value, the value of the car at year 1? What am I going to do here?
Math.
Yes, math is always the correct answer, but not fully correct. Multiply by what? 2/3. So we're going to take 1,800 or 18,000, sorry. And we're going to multiply by 2/3. Okay. What am I going to do on year 2?
Same thing.
Same thing. So how am I going to write that?
32,000.
Not quite. So we're going to say 18,000 times 2/3 times 2/3. We're multiplying it by 2/3 again. Okay. What am I going to do for year 3? Okay, so what do we do for year 3?
Multiply it by 3 2/3.
Multiply by 3 2/3. 18,000 times. Okay, so 2/3, 2/3, 2/3. What are we going to do at year 6? 6 of them. Is there an easier way to write this than writing 2/3 6 times?
1,800
Wait, what? 18,000 what?
times 2/3 times 6?
Cubed.
Or like to the power of... Or,
18,000 times
Cubed.
2/3. We'll do the 6 for this one, but for year 3 it would be cubed.
Yeah, that's
So that's what I thought you were saying. So that's why I went back to that one. So 18,000 times 2/3 cubed. So what would it be for t years?
The same thing, but instead of 6,
Right, it'd be the t. So we have 18,000 times 2/3 to the t power. So now we're going to write an equation relating the value of the car in dollars V to the number of years t.
I wish I had dollars.
All right, so what would my equation be here? What has my equation been?
1,800 times 2/3.
18,000
Why do I keep saying 100? I don't know.
times 2/3. What's my years? What's the variable for years here?
Why?
What's it in the in the problem? T.
T.
Okay. And what value do I not have yet? What letter have I not
X.
used? V.
OV.
So V equals 18,000 times 2/3 t. Use your equation to find V when t is 0. So if t equals 0, we will have V equals 18,000 times 2/3 to the 0 power. What is 2/3 to the 0 power?
0.
1.
1. So V equals 18,000 times 1, but we can take away that times 1 because anything times 1 is that number. So the value of the vehicle with the car, that's what it was. The value of the car at 0 years is $18,000. Okay? All right. Last one. A different car loses value at a different rate. The value of this different car in dollars D after T years can be represented by the equation D equals 10,000 times 4 divided by 5 to the T power. Explain what the numbers 10,000 and 4/5 mean. So what does 10,000 mean?
How much it's worth?
It's going to be the initial cost of the vehicle or the car.
Okay.
The initial value.
And then the other one would be
Of the
in
car.
Years. It can,
So the 4/5, what does that tell you?
the years.
Not the years. What happened whenever we multiplied by 2/3 up there? What did it do to the value of the car?
Brought it up. Down.
Went down. So 4/5 is the rate that the value
Backing up. What time do we get out of here?
decreases.
You see all this stuff on my desk? No question.
Okay, so the rate that the value decreases each year. Okay, you do not have practice problems today, so make sure if you have any missing assignments, you work on those tonight.